All right, welcome back. We're going to finish up the 19e notes. This is the second half of the notes. So we just finished taking the derivative of this function here. Okay, and now we're going to do the derivative of this function here. We're going to do b. Now, this is a little different because this, we have our variables are in the denominator. So what we have to do first is we have to actually move these variables up into the numerator so that we can take the derivative. Okay, so let's just do this. F of x is 7x. Let's go to the first. Minus 4. And then that's x to the first on the bottom moves to the top. So it's x to the negative first on the top. Plus 3x. That's x squared on the bottom. So it's going to be x to the negative second on top. Okay, so that's the function in the form that we want so that we can take the derivative. So now f prime of x is 1 times 7 is 7. And then we go x to the 1 minus 1 gives us, let me get rid of that. So 1 minus 1 gives us x to the 0. So that's just going to be 7. Okay. And then we do negative 1 times negative 4 is positive 4. And then we do negative 1 minus 1. So that's going to be 4x to the negative second. Okay. And then we do negative 2 times 3 is negative 6. And then again, we're going to subtract 1 from that, so it's x to the negative third. Okay, so that's the derivative, but the form we want to write it in is how it started, which was in fraction form here. So f prime of x is going to be 7 plus 4 over x squared minus 6 over x cubed. Okay, and there's our derivative right there. Okay, let's try C and D and then look at another set. Actually, we got a couple other examples after this, but they're not so bad. All right, C. This is a squared there. Hard to kind of see now because I wrote over the top of it. But again, we want to rewrite f of x without this variable in the denominator. So that's x to the first, that's x to the first. So we go 2 minus 1, so this is really just x to the first. And then x to the first over x to the first, those reduce each other out, so it's plus 4. And then this is negative 5x to the 0, right? And then we go 0 minus 1, so this is really 4x to the negative first. Okay? Oops, why did I mess that up? Let's get this back. So, sorry, plus 4 minus 5x to the negative first. That's what I meant to do. Okay, and now we've done the hard part, and now we get to do the easy part, which, well, hopefully the easy part, which is the derivative. 1 times x is simply x. Well, excuse me. Let's think of it this way. Think of a 1 out here. So 1 times 1 is 1, and then now we take x to the 1 minus 1, which is x to the 0, so we just get 1 here. And then remember, this is 4x to the 0. 0 times anything is going to give us 0. And then we take this negative 1 times the negative 5, which gives us positive 5. And then that's negative 1 and negative 1, so that's x to the negative second. So if we rewrite this whole thing, f prime of x is 1, and it's plus 5 over x squared is our derivative of that. Okay. All right, let's do this one here. That's a 3. Again, sorry, kind of hard to see. Let's just do this. Let's just change this here into minus, and then we move that x squared to the top, and we get x to the negative, second. Right? So, taking the derivative, we can go straight to the derivative on this one here. 3 times 2 is 6. We subtract 1 from that, and we get x squared. That's x to the first. 1 times negative 5 is negative 5. Subtract 1 from that, and your x's are gone, so it's just negative 5. Remember, this is 2x to the 0. 0 times 2 gives us 0, so we just, when we take the derivative, that's gone. And then we take negative 2 times negative 1, which gives us 2. And we subtract 1 from that, so it's plus 2. And that's x to the negative third, or again, if we just skip straight to the end, we just put that over x to the third, and there's our derivative. Okay? Okay. A couple other examples to look at, and we are done. Example 6, page 616. Find the gradient function. Remember, gradient is slope of f of x equals x squared minus 4 over x, and find the gradient of the tangent to the function at the point where x equals 2. Okay? So, first thing we're going to want to do here is let's take the derivative of our function. Okay, so f prime of x is, let's see, remember this is, let's turn this into x to the negative first, right? So 2 times x, and then that's going to be, subtract 1 here, so that's just going to be 2x to the first, and then negative 1 times negative 4 is positive 4. We're going to subtract 1 when we're done, so that's x to the negative second, and since I guess we can just put it over x to the second. There's our derivative function, right? Okay, so now that we've done that, we have our derivative function, and now it's asking us to find the gradient or the slope of the tangent to the function at the point where x equals 2. Okay, so just so you can kind of get an idea of what we're doing, here's a not so pretty picture. Let's say you have, I don't really know what this looks like, but let's just say it looks something like this here. What we're going to do is say here's x equals 2. They're asking us to find what's the equation or what's the slope of this line that's the tangent to this function at the point where x equals 2. Okay? So, again, find the gradient. So all we're going to do here is we took the derivative, so that's going to help us find this slope right here. So all we need to do, since we need to find it at 2, is just plug 2 into the derivative. So what we're really doing is f prime of, instead of x, now we're plugging 2 in for x, equals 2 times 2 plus 4 over 2 squared. Okay, so that gives us f prime at, oops, I keep putting x in there, but it's supposed to be 2. Because again, that's what we're finding at x equals 2. 2 times 2 is 4. 4 over 2 squared, that's 4 over 4, so that's plus 1. So f prime of 2 equals 5. Okay, so what this means is the gradient of the tangent to this function at 2, the slope is just going to be 5. Okay, so again, this is not necessarily this function. I just was making up a graph, but just trying to help you understand what you're doing there. Okay, one last example, and we'll call this good. Example 7 from page 616. If y equals 3x squared minus 4x, find dy over dx and interpret its meaning. Okay, so the derivative of y with respect to x is, okay, so again, same thing. Oops, 2 comes out front there, so 2 times 3 is 6x. Subtract 1, so that's 6x to the first. We don't have to write it in there. And then 1 times negative 4 is negative 4. Subtract that 1, and the x turns into 0, so we just have the derivative is just 6x minus 4. Okay, now what this means here, okay, is that we can find the gradient of the tangent of the function y equals 3x squared minus 4x at any point by plugging that x value in. So we can find the slope of the tangent to this function just merely at any point by plugging in a value for this here, okay, x value. Okay, I know we're running kind of close to the end here, but let me show you what I mean. Okay. Okay, so here's the function 3x squared minus 4x. Okay, on here. So if we wanted to know what the what the slope is here at, say, 2, instead of having to go through and try to draw the tangent line and trying to calculate what that is, all we have to do now is just plug in 2 for this function here. So 6 times 2 is 12. 12 minus 4 is 8. So the slope of this line right here at x equals 2 is going to be 8. Okay, so that's one thing that we can figure out from that. Okay, and then the other thing is, and I really think this is the big one. This is kind of the nice part. The instantaneous rate of change in y as x changes. So basically, what is this, like, that's really what the slope is when you're finding, like, say if you're finding the tangent at 2 here, the slope is 8. That means that it's the rate of change at that point 2 is 8. Okay, so it's going up 8 over 1. So, and as you get closer, like as you go farther out, as you get to 3 on this one here, the instantaneous rate of change is going to grow. It's going to grow more and more and more. Okay, so those are the two big things, and let me write those down for you so you can, in case you need those. Okay, so here it is again. So again, we can find the gradient of the tangent of the function y equals 3x squared minus 4x at any point by plugging the x value into the derivative right here. And then also, this is the instantaneous rate of change in y as x changes. Okay, so you should now be able to say I can calculate the derivative of a function using the rules of differentiation and interpret its meaning. Okay, if you have any questions, please ask. Thanks.